In this lesson, we're going to look at measures of central tendency. We usually think of these as being the mean, the median, and the mode. So our objectives here in this lesson, to be able to summarize data using these measures, to understand the difference between and when to use the mean versus the median, and to be able to use the TI-84 as well as other software to find these. So some terms you should know. Arithmetic mean is just the average of the values. The median is the middle number when the data is sorted in ascending order or descending order. The mode is the number that occurs most often, or bimodal, when two values occur with the same greatest frequency. And weighted mean, when the values being averaged are different levels of importance. For example, test 1 20%, test 2 is 30%, the final is 50%. That would be a weighted mean. Okay. Let's use the TI-83-84 to find the mean, median, and mode for this data set. And I will pause while you get your TIs out. Okay, let's go ahead and reveal those screens. Step 1, we put the data into L1 by pressing the Stat button. Step 2, you're going to scroll over to, you can press Stat again and scroll over to Calc and select one variable statistic. You want to get used to this menu structure here. We're going to be going to it all the time. And then step 3, once you press Enter, you should see our data come in. And so we see here's the mean at about 81.07. And if you scroll down, whenever you see this arrow here, that means there's more information down. I can't show it on this screen, but if you scroll down, you should be able to see the median. And with this data set being as small as it is, we can look at it and figure out the mode. Okay, let's find the mean and median for this data set. Let me show you a live shot here of the TI. Let's scroll out of that. We're going to press Stat and then select Enter. If you have any data in, we're going to take it out, so scroll up and press Clear, Enter, scroll up, Clear, Enter. If for some reason you press Delete on those, which you don't want to do because they go away, and we're just typically used to seeing the L1 and L2, what you do to get those back, you could go up here, press Second, Insert, and then actually stick in L2. Most people forget how to do that. The easy way to get everything back to your nice happy place is to press Stat and number 5, Set Up Editor, and then press Enter, and that should put everything back. Notice when I press Stat Enter, there we go. So now I'm going to put the values in: 90, 90, 85, 77, 82, 82, 82, 100, 93, 64, 65, 80, 52, 93. You definitely want to get used to using this menu. We'll be using it all the time. So make sure you get used to the Stat button and how to put data in L1, L2. Okay, so let's scroll up here. It's probably worth it to make sure you put it in right. 90, 90, 85, 77, 82, 82, 382s. We've got 100, 93, 64, 65, 80, 93. Okay, I'm more likely to make a mistake than you are since I'm using this virtual TI. Anyway, now we're ready to find the mean and median. What we do on this is we press Stat, and you're going to scroll over to Calc. We want to calculate something with something we just put in the Stat menu. So press Calculate, and this first one variable statistic. That's what we're going to do. Press Enter. You don't have to press this, but I usually press second L1. This tells me to do the list 1. Now if you don't press anything, it will default to list 1. Press Enter, and there we go. There is our mean, 81.07, and I can scroll down a little bit and find my median at 82, as well as some other values we'll want to find out in later sections. So you've got everything right here. This is a really nice feature on the TI. Okay, skewness. So how skewness relates to the mean, median, and mode. We've seen skewness in an earlier lesson. So skewed left, again, skinny on the left is the skewed left. When we have skewed left, the mean is going to be to the left of the median. when, and the mode is this hump here, right? So that one's pretty easy. The hard part is sometimes determining the median and the mean, its relative position. When we have a relatively normal shaped or symmetric shaped, they're all the same, or they're close to the same. They're never going to be exactly the same with real data. And finally, skewed to the right, the mean is to the right of the data. Not to the right of data, but to the right of the median and the mode. So example 2. Find the mean, median, and mode of this data set. So the following data represent the number of available cars in a household based on a random sample of 50 households. Find the mean, median, and mode. To find the mean and median on the TI, press the Stat button, and then press Enter to enter the list. Go ahead and put your list in. I've already done that. I assume you can do that. And then we're going to press the Stat button again, scroll over to Calc, and select one variable statistic, and press Enter. And then press Enter again. Or you could have put L1 there. And we see we have a mean of 1.9, and we'll scroll on down to find the median of 2. So using the TI, we get a mean of 1.9. Here I was able to show you both screens. And the median of 2. So I have that marked right there. And we'll worry about these other, what these other variables represent a little bit later. Some of them are easy. I mean, min, I think you got that. Max, you get that. But we'll talk about what Q1, Q2, and these little symbols here mean in a later lesson. So using statistical software, again, you don't have to, as with this whole course, if you're not using Minitab for any of these, then you can skip all the Minitab ones. You can use the table of contents on the left and just skip it as soon as I get to the Minitab lesson on this, or if you're not going to use StatCrunch or Excel or whatever, you can skip around on these. Okay, the way we do this in Excel, we need to put the Data Analysis Tool Pack on. If you don't have that, press the File button and go down to Options, and then go to Add-ins, and we need that Analysis Tool Pack there. So if you don't see it there, scroll on down to where you see Manage Add-ins and press Go for Excel Add-ins. And make sure that Analysis Tool Pack is selected, not the VBA, just that top one, and then press OK. And then it should show up on your toolbar there at the top. Let me move this down a little bit. Under the Data tab. Okay, so press Data Analysis, and we're going to do Descriptive Statistics, and then press OK. Okay, we're going to click that button there and highlight my data all the way down. So there are 50 data points, and then we'll uncompress that. Output range, and just put it somewhere where I can actually see it, somewhere near the top. Just click anywhere in there. We want summary statistics, and then press OK. And there we go. There's our, we can adjust this a little bit. There's our mean at 1.9, and we have our median and mode at 2. Okay, StatCrunch is really easy to do this. We don't have to add anything in. It's kind of already there. Just press Stat, Summary Statistics, and we got this in a column. So select Columns. Okay, now we're just going to double click on that first variable and then click Next. And I'll just take the default values and make sure a mean and median's in there. Press Calculate. And there we go. There's our mean, and there's our median. So the mean and median, a closer look. So the median, let's just look at some of the characteristics of the median. It is not affected by outliers. If I have a data set, and let me just make one up real quick, 3, 4, 5, let's just use a data set 3, 4, 5. If I've got a median, if I've got an outlier that comes in here of maybe 100, our median doesn't change that much, right? The median in this data set was 4. The median in this new data set is 4.5. Not that big a deal. But the mean would change significantly. So the median is not really affected by outliers, whether it be large or small. It's called a robust statistic. And it's the preferred measure when the data are skewed. So if you have skewed data, you should report the median for your measure of central tendency. If nothing else, report the median and the mean so people can tell about the statistic. The mean is affected by outliers, extreme values. It's used in most of our theoretical calculations. When we start doing inferential statistics in later lessons, the mean is used in our formulas. And there's a reason for that we'll get into later. Okay, example 3. Teachers' salaries. The following data represents salaries in dollars from a school district in Greenwood, South Carolina. So these are the salaries of a sample of, we got here 1, 2, 3, 4, 5, 6, so 12 salaries. First, assume you work for the school board in Greenwood and do not wish to raise taxes to increase salaries. Compute the mean, median, and mode, and decide which one would best support your position not to raise salaries. And then second, assume you work for the teachers union and you want to raise for the teachers. Use the best measure to support your position. And explain how the outliers can be used to support one or the other position. And then number 4, if the salaries represented every teacher in the school district, would averages be parameters or statistics? And we've talked about this in an earlier lesson on what parameters and statistics mean. And which measures of central tendency can be misleading when a data set contains outliers? We just talked about that. And when one is comparing measures of central tendency, does the distribution display any skewness? And explain. So pause the video here and really see if you can go through this one. This one's kind of pulling together a lot of the stuff that we've already talked about. Let me show you how to do this on the calculator rather than just give you the answer. Okay. Press Stat, Edit, and we're going to enter the list in. If you don't see these L1, L2, L3, maybe you messed them up before or deleted them, if you press Stat and go to number 5 and press Enter, all that should come back. So press Stat, Edit, and there we go. And we'll go ahead and type this in. So 10,000, and then 11,000. Looks like I left one out. So let's see. So 10,000, 11,000. Ooh, 11,000 was twice. I bet some of you caught that. So let me insert that value in. 11,000. So it's always good to make sure you have the data in, because we would have missed every question pretty much if we didn't do that. So I looked to see. I counted them. This was an easy set to count. So I counted there was 12, and I saw I initially only had 11 values. So always take a second look, especially when your data set's not that large, to look to make sure you typed it in right. Okay, so now let's find the mean and median. I mean, we can quickly see the mode here is 11,000, but let's do the mean and median. So stat, I'm usually not as concerned with the mode. It's really more important the number of modes rather than the mode itself. So stat, scroll over to calc, and just select one variable statistic. If you want to, you can always press the list that it's in. If you don't select L1, it'll default to L1. That's a good habit to get into. Just go ahead and put the list that you've got it in. Okay, so here is our mean. So I'm going to write these in here. We have, the mean is about $22,921. We'll just round to the nearest dollar, so $22. And my median, I'm just going to scroll down a little bit until I see the MED. So the median is what? 16,500? Okay. So now let's first assume we work for the school board. And we want to say, hey, these teachers are making pretty good money. Although this data set may be kind of old because 22,922 is not great money these days. But if we wanted to support our position, we would use this value here at 22,922. If I'm the school board and I say we shouldn't raise salaries. Now on number 2, if we assume we work with a teachers union, we should use the median as our value. Now, for being honest, which value should we use? This data is relatively skewed, right? Because we've got this outlier here, and when we have outliers where we have skewed data, it's better to use the median. So outliers can be used to support our mean position, right? Our MEAN for our statistical mean and sort of a mean position with regard to teachers, right? So the outliers can affect that. If the salaries represented every teacher in the school district, would it be parameters or statistics? So if we only had 12 teachers in the entire district, that is going to be the whole population. And remember what I said earlier? Population P for parameter. So it'd be a parameter. If it was just a sample, it would be a statistic. Which measure of central tendency can be misleading when the data set contains outliers? We just mentioned that, and that is the mean. When one is comparing measures of central tendency, does the distribution display any skewness? And we can look at this right here. And generally, if the mean and median aren't relatively close, there is going to be some skewness. So I can do a quick histogram here. So I can do a second y equals. Let's turn my stat plot on. Scroll down, and let's pick the histogram. And I've got all my data in L1. I don't have a frequency column in L2. So let's do a zoom 9. Resume stat. Ooh, that doesn't look good at all, does it? And that's because I've got this outlier here. So we've got most of our stuff here and down here. I could adjust the window. I'm not sure how good it's going to do because my data is so spread out like that. So there's my min, there's my max. Maybe if I made my scaling, it's right now $19,000. Maybe make it $5,000. I might get to see some of the others. I'll just press graph, and there we go. So definitely a right skew here, right? Because it comes back down. I could probably go one more and make that maybe 3,000. And there's that outlier. See, the outliers will always mess up your data. Kind of hard to tell there. Okay, and I've got these typed out for you here just so you can have them easy to read. Example 4, the acidity or alkalinity of a solution is measured using pH. A pH less than 7 is considered acidic, and greater than 7 is alkaline, where 7 being neutral. The following data represent the pH in samples of bottled water and tap water. So let's find the mean, median, and mode pH for each type of water and comment on the differences between the two. And part B, suppose the pH is 7.10, and I should say tap water, not tab water, was incorrectly recorded as 1.70. How would this affect the mean and the median? Okay, let's go over to the calculator again. And I'm going to put this data in. So I'm going to clear out, press stat, edit, and I've got some data in L1. I'm just going to press clear and enter. Don't press delete. That's what a few of you will do. If you ever do that, the easiest way is just to press stat and then number 5 and enter, and it'll get back all your stuff. Okay. So I'm going to be typing this in, and we can fast forward through this and get to the end if you want. Hopefully I'll be able to fast forward this on my own. Okay, and we're back. So I have the tap water in L1 and bottled water in L2. If you start using the calculator for a lot of these, you can always go up here and relabel the L1 and call it something else. I usually just leave it and sort of remember it. Okay, so I'm trying to find the mean and the median. So I'm going to press stat, edit, stat, calc. I could go to 2 variable statistic, but, and that would give me, there's the mean for the first one, for X is L1, and then Y is L2. But the problem is I don't get the median on that. It gives me everything else, but not the median. So I have to do stat, calc, 1 variable statistic, and I'll put L1 just for emphasis, and enter. So the mean of this, and I'll go ahead and write it up here, the mean for the tap water was 7.5. And I'll use a big M for the median. Let me scroll down here. Is about 7.5 as well. $7.49. Okay, basically the same. And now let's look at stat, calc, 1 variable statistic. This time we have to press second L2, otherwise we'll find L1 again. And so here the mean is 5.19, and the median, big capital M, is 5.22. So really no outliers here, probably a pretty symmetric distribution if I did a histogram of it. Okay, so find mean, median. We really won't worry about the mode. Looks like mode for tap water is 7.47. Bottled water, I don't see any off the top of my head that repeat. So it's mode not that important with these. So comment on the differences between the two. Each 2 types of water. So certainly the average pH is greater for the tap water than it is for the bottled water, right? Both the mean and the median. They're both practically the same, so it doesn't really matter which one we would use. There aren't any outliers in this. If I were to do a quick histogram of the data, so go up here, Y1, stat plot 1 is on. Let me press enter, it's on. I've got that, so I'll do a zoom 9. So roughly symmetric here. And I can do the same thing with L2. So go back to second Y equals, and let's change that to L2. And again, we'll do zoom 9. This one's a little skewed left, right? Got a little skewed to the left here. So we'd expect a little bit different here. Means a little bit less than the median. Okay, now part B. Suppose the pH of 7.1 in the tap water, that's just irritating, isn't it? Tap water was incorrectly recorded as 1.70. So where is that 7.10 right here? So if instead of putting 7.10, if we had accidentally put 1.70 when I was putting it in here, when I went into stat, edit, so 7.10, if I had incorrectly put 1.70, okay, how would that have affected the mean and the median? So the mean would have been affected, right? The mean would have really been pulled down from 7.5 to, maybe 7 even, or upper 6s. And the median, though, would have stayed basically the same. It may tick a little bit, but not nearly as much as the mean. Remember, the median is a robust statistic. Now, we don't have to do this to figure it out, but we'll go ahead and, just for kicks, let's find out what that is. Let's clear that out. So stat, calc, 1 variable statistic, second L1. And yeah, we got down to 7.05, so a pretty big chunk, but the median, let me scroll down here, you'll notice really didn't move at all. 7.485, stayed exactly the same. And so that's what we mean by being a robust statistic. It is, it really is not affected by outliers. Okay, let's return to the body temperature problem from an earlier lesson. That is on the next slide. And let's compute the mean and median for the body temperatures. And we'll re-examine the histogram as well. Okay, so here's the data. This would be somewhat of a pain to put into the calculator, although, you know, it'd take you 5 minutes. I'm sure you probably worked longer on math problems than 5 minutes to get that data in. The problem is that there's a likelihood of you putting something in wrong. You have to be really careful with this. I will post the data set online, so you should be able to just zip it right into Excel or StatCrunch or Minitab, whichever program you decide to use. Okay, let's find this mean and median on the TI. Press Stat, then Edit. Save the trouble. Went ahead and put that list in. You don't need to watch me type all those in. Okay, let's press Stat again and then select Calc and select the one variable statistic. And you can put L1 after that if you want. We'll go and do that this time, second one, and press Enter. And there we go. There's our mean at 98.249. We can scroll back down and find the median at 98.3. Okay, now if we want to do a histogram of this, we already have the data in, so let's make sure we turn the stat plot on. Press second y equals. It is already on, but just make sure you scroll that, make sure that's on, and make sure that histogram is selected. Make sure that frequency is at 1, because we don't have frequencies in there, right? Into L2. So zoom number 9, and there is our histogram. Looks good. I can adjust my window a little bit. We can see the minimum's 96.3. While we look at our Y scaling, we can look at Y min, Y max, and the X scaling, and so forth. I can trace on that, and I can see how many values fall within each class interval, which is kind of nice. Okay, so when we crunch that data out, in the same way we've done the last few, here is the histogram and Minitab that we got, and here's the histogram on the TI. They look pretty similar, but they're a little different, right? I mean, they have different bin widths, and the number of bins is a little bit different. Again, we're really just concerned with the basic shape. We see this is somewhat mound-shaped, right? And now we're looking at the mean. So the mean here is about 98.25. The median's about 98.3. We would expect these to be pretty close, right? Because we have a relatively symmetric shape. So the mean is right there at 98.25. The median just a tick over to the right at 98.3. Okay, again, assuming we've already installed that analysis tool pack, I click on the Data tab. This is in Excel. And I go over to the Data Analysis button, and we're going to do descriptive statistics here, and then press OK. Input range, click that button, and then select all these in column A. $130 values there, and that first value is a label, so I'll call that a label. Let's put this in the output range. Rather than a new sheet, we want to stick it right here so I can see it a little bit easier. And we'll click on Summary Statistics here. And click OK. And there we go. So we have our mean at 98.249, our mode at 98, and median 98.3. Now the output in Minitab in Excel, We need to be able to read this fairly easily, so just focus in on, sometimes it gives you values you really aren't interested in at the time. So there's our mean, and here's our median for the Minitab output. And then the Excel output, we get exactly the same mean. It's rounded a little bit differently, and the median is right below it. Okay. In later lessons, we may be interested in these numbers, but in this case, we're just going to focus on these two.